of ISS is to enable the digital economy by, and our mission is to develop digital talent, through education, through research, through consulting, and through career services. So so it's a practice-based education. So instead of teaching a lot of theories, we teach you theory plus hands-on. So our focus is more on application, rather than on theory. There are three groups of, there are three areas in which ISS is focused on. So we have the graduate program. So the graduate program includes includes the master's program, of which I believe we have like 4 streams. There is the software engineering, there's the data analytics, there's the AI, and also there is the digital leadership. So those are the four master's program. And then there is the graduate diploma program. These are for people who wants to do a conversion, from other industry, from non-IT based industry to an IT one. And then also there is executive program, short courses for you to continually, enhance your knowledge. So this is the this is in fact, this is like the third or fourth webinar that we have actually run in this series. Okay, I appreciate that, at the end, please send us a feedback so that we can further improve the program. Here is the please scan this QR code, right? So we will send you the video. So we have got other upcoming webinars. The next one is going to be 11th June. So it's going to be introduction to TensorFlow and Keras. So basically, my colleague will be running this, will be conducting this. They will take some data from the data graph and do some, do some analysis on it. So that's one. And then further out, about a month away, also by the same colleague, Lisa, she'll be doing text processing using the Spacey library. Most of you, if you have done text processing in Python, you have heard of something called NLTK. NLTK is a slightly older library. Spacey is a new library, and it's really, really good. So she'll talk about those two events. So you can go to our website to find out more about this. Okay. So what I'm going to do is this. We'll start off with gRPC. So if you do not know what is gRPC, you've come to the right seminar. So today we're going to talk about gRPC and how you can use gRPC as an alternative to REST API. By the way, you can get the slides by going to this link. Okay, so I'll keep it up here for a minute. So for those of you who want to look at this slide, there's not really a lot, but if you want to do some annotations on it, whatever, I'll give you a minute to go to the slide if you want to. And I can take some questions. Let me see. Please don't hesitate to ask questions. Okay. So there are a few more. Everybody. Sometimes I do speak a little bit too fast. So if I'm talking too fast, please do stop me and let me know. Let me know so I can slow down. Or if you want me to go through some concepts again, I can probably go. I can probably spend a little bit more time on the concepts. Okay, so I'll wait for a little bit more for people to get a reference to this slide. So maybe I can just copy this thing and post it on the, thank you. Somebody has done that. Excellent. Okay. So what we're going to talk about is this. So the objective of this course is to introduce the audience, which is you guys, to gRPC by developing a really simple service. So we're going to look at, we're going to develop the service, we're going to develop both front end and back end and the middle part as well. So we're going to develop a server, a backend server, using gRPC. The server will have one service. Well, not service. It will be one service, but with one method call, to get some data. That's the first one. Then we're going to write a client, a special client, a specific client, just to call the server. gRPC uses a binary protocol, which is not HTTP. So what we're going to do is that the third part, we're going to develop an HTTP gateway, also part of the gRPC package. So 3 of them. So with the gRPC gateway, you can use HTTP, standard HTTP. So in other words, the gateway exposes a gRPC service as a HTTP to HTTP client. Okay. So this presentation assumes that you know at least one programming language, and preferably the programming language, preferably the language that you know is a language with pointers. So in other words, not programming language like JavaScript or Python. Although knowing that can help, but we rather that if you know C or something like C or C++, because we'll be using Golang to develop the service. So also I'll use this workshop webinar as an introduction to Golang. So if you know a programming language, then I will explain some concepts in Golang, things like how interfaces are implemented in Golang, how to create structures, how concurrent processes communicate in Golang. Okay, so we'll use some of those features when we are developing the service. So as you probably know, just a very quick introduction to HTTP. So as you probably know, HTTP or RESTful API uses HTTP under the hood. So HTTP, the protocol is broken up into 2 parts. You have the verb. So you got like get, post, put, right, delete, patch, right, trace, hate, whatever, followed by a resource. So essentially what we are saying is this, you apply the verb to the resource, right? You apply the verb to the noun, okay? And depending on what verb you're using, there's a whole bunch of query string, or the body may change, okay? So the thing about HTTP is this, it's really easy to use because first of all, the protocol is text, okay? So you can open up, you can use curl or you can use telnet, just telnet to the port, and then you're able to get the information. Okay. The thing about HTTP is that it is not exact in the sense that if you're developing a service-oriented architecture, right? There is no way for you to find out what the service, let's say this is a client, this is service, right? There's no way to find out what the service is offering. How is this offering? So the only way you can find out is, first of all, is to read the documentation. So for example, if you want to connect to GitHub and you want to write something to GitHub, develop a client for GitHub, you have to go to the GitHub documentation page, right? Or if you are using AWS services and you want to write some special client to do some provisioning of AWS resources, you need to read the documentation. Okay, there's no way to magically for you to discover what are the services, what are the parameters, what are the return type. Now there are some remedies around this, so you can use something like Open API specification, but those are add-ons rather than mandatory. So in other words, I can create a service without Open API specification to enforce the call. Okay. So HTTP is very good. It's very simple. It is ubiquitous because when you deploy like a web server, anytime you get a free HTTP service, right? You get opportunity to deploy a RESTful service. On the other hand, gRPC or RPC is based on this idea that instead of viewing the service, instead of interacting the service through a series of messages, if you send a message, in RPC we interact with the remote service as if like it is a local function call, local procedure. So RPC, if you do not know, stands for remote procedure call. So basically what happens is this. Let me see if there are people who are waiting. Okay. So like when you write a Java or Python program, right, and you write a function, right, so you make a function call, right? So RPC behaves exactly like that. It makes, so you're just invoking a function, but this function, instead of residing locally in your program, resides on the remote server. So what happens is this: when you make a call here, like this, right, the call goes, the call is intercepted by some underlying thing called a stub. The stub will then package your parameters. So for example, if the function has parameter, you package all the parameter into a package, and then you send the data over the network to the server. So in other words, it will marshal the data and send it across the network. Okay, and then on the server side, when the server receives the the the, the invocation, the skeleton on this side will unmarshal, unpack the data, okay, and then pass the call to the server, right? So pass the call to the server processes the call, returns the data, the skeleton package, or returns the result, the skeleton packages the data, sends the data back out to the network, and that goes back up to the stub, and then you'll receive the result. So when you call, let's say find book by ID, you pass in the parameter, right? You just get back the data on the client side. On the server side, you write the function, the parameter you will just receive the parameter. So on the server side, right, when you implement the function, it's as if like it is a local function, right? Whereas the result is coming remotely, okay? So that is how RPC works. So RPC has been around for many years. So if you use frameworks like Cobra or Microsoft Component Object Model, or even if you use Java, RMI, Remote Method Invocation, or even if you use SOAP-based map services, this is going back maybe 20 years ago, right? If you use XML SOAP, those are all RPC, this style of programming, okay? This style of programming, and gRPC, of course, okay? So with RPC, what you need to do is this: you need to write, you need to get this stub and this skeleton, because this is where the magic happens, okay? And also with RPC, right, there are certain things you cannot do. So for example, like if you write in Java, for example, let's say you write a function, a method in Java, right? So as you know, in Java, objects are passed by reference, okay? So if you write a method that has got an object here as a parameter, in Java it's passed by reference into the method, right? In RPC, there is no such thing as passed by reference, because you have to go over the network, right? So that the reference will actually be created into a copy, into a value, which pass across the network. So when you use RPC, right, there are no all the parameters are not passed by reference, they are passed by value. Everything is passed by value, okay? So if you pass in, so previously, if you write a function, a method, and you pass in by reference, you pass a parameter in by reference, and you hope that the function, by changing the reference, will also change the object. If you convert to RPC, it doesn't work anymore, because we are now passing by value. So anything that you want that is changed inside the RPC has to be returned as a result. You cannot rely on the reference to get back your result. Okay, so this is very important in RPC. Okay, so it changes the semantics of the call, or it changes the semantics of the language slightly. Okay, so typically the way it works is like this. So another thing about RPC is that if you don't define the method, if you don't define a function, just like function calls, you don't define a function, there's no way for you to call the function on the server. Unlike HTTP, right? Even if there is a post, it's not defined here, you can still call it. The most you can get is a 404, right? So in RPC, you cannot do that. There's no way to call, okay? And also in HTTP, even if I know what to call, right, I can pass in a whole bunch of rubbish parameters, okay? It's up to the server to interpret. If you use RPC, you can only pass the parameter that is defined you can only pass the defined parameters and nothing else. Okay, so RPC is very, very strict, and your invocation is very, very exact. So the way RPC works is like this, or gRPC works like this. You write a definition file called proto file, and then you compile the file, okay, using a compiler called proto-C. The proto-C will generate two things. You generate the stubs and you generate the skeleton. The skeleton is for you to implement the server. The stub is for you to implement the client. Okay, so the stub and the client will handle all the communication. So in other words, with one proto file, you can say, you know, I want to generate a Golang backend, but I want a Java front end. So, and those two programs will automatically work. Okay, you don't have to worry about, you know, oh, should I use XML, you know, for data exchange, or should I use JSON for data exchange? Okay, most RPC and gRPC in particular handles all the data conversion for you under the hood. Okay, so a typical workflow will be like this. You write the protobuf or the gRPC file. You compile the file using proto-C. When you compile, you can specify one of these things, whatever is it that you want, language that you want. Then you implement the server and the client using these files. Okay, right? So in gRPC, right, there are 4 types of services, backend services you can write. Okay, 4 types. The first type of service is a unary service. What we typically call a request response service. So a client calls the server, passing some data, the server responds with the data. So this is one request response. So this will be like our typical HTTP. HTTP, you make one request, you get the response back. Okay, so this is the unary style. Okay, the second style is the streaming server streaming. So basically, what this means is this: if the client makes a call to the server, and the server returns the result one at a time. So it trickles it back. So why would you want to do this? So in situation like, so when would you use this? You use this in situations where the result is a very, very big file. So for example, like if you are implementing a service for streaming movies, okay? And you know, the movie like Netflix, for example, you know, the movie is really, the movie file is very big, right? So rather than doing a unary one where you dump the whole file back, right? The whole file back, okay? And also, you know, if there's a break in the connection, especially if over a big, you know, over an unstable connection, then you need to resend the whole file again, right? In a streaming environment, you can send like, you know, how should I say, you know, maybe, you know, 500, you know, 8K at a time, or 8 meg at a time, right? So if it breaks, you can start from where it breaks and continue from there. Okay, so that's server streaming. Client streaming is the client sends data to the server in bits, right? And then the server responds in one go. So this is for perhaps uploading of a very big file. Okay, and of course you got bidirectional where you can have streaming on both ends. Okay, so today we'll be implementing this guy. Okay, so we'll perform a search on the database, and the results will be coming back one record at a time. Okay, so this allows flow control on the client side. Okay, so typically, where is gRPC used today? Today, gRPC is used in a lot of very high performance, typically intranet, inside your data center, like like your cloud, your VPCs or whatever, and you need really, really fast response. Okay, so gRPC will be the one. Also, if you're using Kubernetes, a lot of the Kubernetes controllers, internally controllers, uses gRPC. Okay, so what we're going to do now is this. We are now going to write our service. So we're going to write our protobuf service. We're going to implement the server. Then we're going to test the server with something called reflection. Before we write the client, we'll test it with reflection. And then we will implement the client. And then we'll do the rest API, HTTP gateway. If time permits, we should have enough time, okay? So there are some setup that you need to do you need to get some Go modules. Actually, you don't need to do this because we will be implementing our application using Go modules. So Go modules will automatically download this for us. However, you do need the Proto-C binary. So you can get a Proto-C binary. The Proto-C is the compiler. So Proto-C download. So release. So there are many different Proto-C for generating different languages, like for C++, for C#, okay, for JavaScript, etc. So I will be using the Golang one, so which is just basically Proto-C. So this is the one I'll be using. So let me put this thing on here if you want to get Proto-C. Okay. Right. Okay. So the source, what I'll do is that the source code will be available on this link. Okay. So the source code will be available on this link. Whatever I'm going to implement will be available on this link. The data that we're going to use is a board games gig. If you're into board game, especially during the COVID, so this site, board games gig, actually lists all the board games. You can go if you're interested in board games. This is the site that you should go to. So what I did was this: I went to Kaggle, and Kaggle they do some machine learning on some of the Kaggle data. So I've actually culled the data. I got the data from Kaggle and converted it into a database. Okay, so this is the database. The SQL is here. You can get the SQL. So when you get the code, when you go and check out my source code, you'll get this as well. So I'm going to check this whole thing in. Okay. So this is the database. So the database is called show databases. So the database is called BGG, Board Games Gig. So you can go use BGG, right? Show tables. So there are only two tables. Only two tables. For our demo, for this one, we're only going to use the game. Okay, so you got comments on the game, right? So you go describe game. Describe game. So this is the structure of the table. So you got game ID, the name of the game, the year, the ranking, the user rated, the URL, and the image. So you can, and then you can go describe comments. Comment, and then you can see there's a structure of the comment, right? So so the game ID relates to this, right? So you can do a join table to get the thing. So essentially this is the data that we'll be getting. Okay, so so this is the data. So you get the gID, the name, the ranking, and the URL. Okay, so I won't be getting for the board game. I won't be getting everything. I'll just be getting the just four fields, right? Just four fields: the gID, the name, the ranking, and the URL. Okay, so for the rest of the stuff, you can go and you can go and try to implement that yourself. Okay, so the board game is here. By the way, the database is written for MySQL, but I made it actually I shouldn't say that. I've written the SQL as generic as possible. So it's very generic, but I've only tested it on MySQL. Okay, so your mileage may vary. Okay, so let's start by implementing the board game service server. Okay. So the first thing we need to do is this. If you recall, if you go back to this picture, right? So the first thing we need to do is this. We need to create this protobuf file. Okay. So I'm going to create a directory called messages. Okay. And then inside messages, I'll create a file called bgg, the proto file. So the file ends with a dot proto, right? So the first thing you need in a proto file, in a protobuf file, is you need a syntax. Okay, so currently there's only one, so you can say syntax equals to proto 3. So that's the only one. Okay, then the next thing you're going to have to say is the package name. So the package name for this particular thing, I'll call it BGG, what Gameskip. Okay, then since I'm doing Go, I need to tell it, when I generate the Go files, I need to tell it how to generate the Go file. Okay, so if you're using Java, it'll be Java, or Ruby will be Ruby. So you go look up the documentation for it. So the way you specify is like this. You say option. So option is a protobuf directive. Again, this is a protobuf directive. The package is a protobuf directive. So it's an option. Go package, okay, equals to be like this. Messages is a directory, and then the name of the Go package. So the name of the Go package, the convention is bggpd. Okay, that's what they do. PB means protobuf. Okay, so it's going to generate a Go package for this. So we're going to use this file, right, to generate the stub and the skeleton. So these two guys will be inside this Go package. So if you're doing Java, you will specify, the Java. So Java will be like option. You can put multiple things in here. Java package. Okay, so maybe like com, me, right? Whatever. Proto, and then BGG, whatever you want, like this. Okay, so that's for Java. Okay, so read up the documentation on it. So that's a package, right? So now that we have done that, what we'll do now is this: we will define the service. Okay, so we'll define the service. So for the service, this is what you do. You write like this: service. Okay, then you give the name of your service. So I'm going to call it board game service. Like that. Okay. Then so this is my service inside this package. Okay. So when we generate, this service will be converted into a Golang package, Golang file lot. So now what we're going to do is that we're going to specify what are the functions, what are the methods inside this service I can call. Okay. So the way you do that is like this: RPC, RPC, and then you give the name of your method. So this name here, whatever name you want, right? So I'm going to what I'm going to do is this: I'm going to run this thing, right? I'm going to run this query. Basically, I'm going to return this data, right? So I'm going to call it find board games by name, because we are looking by name. Okay, and the RPC will take 3 parameters. It will take the name that we're going to search for, how many to return, and what is the offset. So this is just relational database, right? How many records to return and how far into the record you want to go, right? Okay. So we will go like this: find board games by name. Okay. So leave that blank first, and then you'll return something, and that's the body. So that's the whole RPC. Okay. So that's the name. So now we need to pass in these parameters, right? So we need to specify these things, right? How to call, right? Because these are the things I need to change. So the way we're going to do it is this: in gRPC, right? We don't have single parameters like int, like string name. So you just string like name like this. Okay. So what you need to do is this: in gRPC, the parameters are coarse-grained. Coarse-grained means you need to create one object to pass it through. So in other words, all the parameters are packaged into one big object, and then it's passed through. Okay, coarse-grained. So what you need to do is you need to create something called a message. Okay, and then depending on how you write, right? The convention that I like to take is this: for every name here, for every method here that takes a parameter, okay, I will call it find board game request, like that. So in other words, this is the parameter that I'm going to use. So I'll call it whatever name followed by request. Again, the convention is up to you. This is what I like to use, because when you write a lot of this, all these messages, you can get lost in all these messages. So the easiest way is to, although it's a little bit long, I'm using VI, but there are other IDEs that will do code completion for you, which you can finish, which you can do the code completion very fast, right? So for me, I prefer the name to be a little bit longer and more descriptive. Okay. So now I need to specify the parameters, right? So the 3 parameters that I will specify is the name to search, right? The limit and offset. Okay. So the way you do it is like this. So you say string. This is a gRPC type. Okay. So the name I'll call query, and now you need to specify a tag. The tag will start from 1. So once you have got this tag, you can no longer change it, because gRPC uses this number here to do encoding. Okay. Then the second one we want to do is the limit, right? So the limit is always positive number. So I'm going to use something called u in unsigned 32. Okay. So limit. So in other words, I'm saying that the limit cannot take negative numbers, only positive numbers. Okay. And then finally, the third one, okay, is the offset. So the offset is 3. So all the tags, right, must be unique. Okay. So again, you generally, generally what I like to do is that I like to give a little bit of space between them. It doesn't matter. It's up to you. Okay. Right. So you can do like this, which is okay as well. Okay. So that's 1, right? So now this is going to returns. So now this is going to return something called find board games response. Okay, board game response. So remember I told you that we are going to implement the streaming server, right? So every one of these response will hold 1 game. So in other words, if I perform this search and I got this result, every one of this record, okay, will be returned in one of these things, right? So to make this into a stream, we put the stream word in front of it. So I'm streaming back the result. Okay, so I need to define what is this response. So we define the response. Like that. Okay, so let's put a count on how many. Right, so you basically go 1, 2, 3, 4. The number of results is coming back, right? And the second thing you need to do is that we need to return this record, right? So we need to return this record, right? So this record, I'm going to create a message to hold it. Okay, I'm going to call this message. I'm going to call this one called board game. Okay, so basically I'm going to do like this. Okay. Okay. So this is this type. Okay. So what are we going to have here? So let's look at what are we returning. So we are returning a GID. So this is a number. So let's have a look at the type. GID is a number. Name is a string, right? And then we're returning the ranking. I think this is a ranking. Ranking is a number. And the URL is a string. Okay, so 2 numbers, 2 string. So we'll come here, and then we'll say the first one is a number. So I do not know whether there is negative number. I presume maybe there are no negative number, but just to be safe, I'll just put in 32. Okay, and then I'll say GID 1, and then string. This is the name of the game. The third one, what is the third one called? The third one is is the ranking. So that's the integer. So I'm going to use so ranking is probably you don't have negative numbers, negative ranking, right? So I'll put ranking. Okay, and then finally the string, the last one, which is the URL. Okay. Okay. So that is our first that's our service. So very simple. We got a request. Okay, so we fill all this thing up, make this call, right? So the result was we stream back in one of these things. Okay, so this response has got 2 types. The the count, which is just basically a count, and then the board game, which is this thing. Okay. So now we are going to generate this. So the way we generate this file, right? The way we generate this file is like this. So we go proto C. So I'm using what's the version? So the version I'm using is 3.12.1. Okay. So you go proto C. You pass in the message. Okay. And then you now say go out. That's the option for it. Okay, so I'm going to use gRPC. You say plugins equals to gRPC colon that. Oh, 12. Yeah. Okay, so let's do that again, right? So now, if you go into the directory, it has now generated a file called bggpbgo. So this is the file. Okay, so before I do this, let me create a make file for you so that you can just run the make file to generate again, and you can study the command. Okay, so let me do this. I'll say generate. Then I'll say proto C. So make sure you install proto C. Okay, messages, and then the file name is this guy, right? And then I'll say go out plugins plugins equals to gRPC colon. Okay, so let's run this and make sure that it works. So you can go make generate. Okay, so that thing generates. Okay, so anyway, let's go back to our file and have a look. So that's the file. So notice the first thing is that this is the Go package. So that's the name according to this line, right? Our message, our package is this guy. So it's message pd. There's a whole bunch of imports. Okay, so this is our first message. This one is this guy. Okay, so notice the four fields here. Okay, I'll talk about this one. So these are called receivers. I'll talk about this in a little while. This thing are called receivers. They basically allow you to implement methods on the structure. It's like a class. Okay, I'll talk more about this in a little while. So every one of this method, right? Every one of this attribute has its own getter. So you will have get gid, get name. So notice, if the field is not, if the attribute is not filled in, it will return to you 0. Okay. So if you got a value that is 0, you got to be careful because 0 can mean the value 0, a gid 0, or the person has not filled in this attribute. Okay. So you got to be careful there. So that's the gid. So this is our request. Again, same thing, the query, the limit, and offset, the type. Okay. Again, it's got a whole bunch of methods like get, query, etc. And then finally, the response. So the tree message, you got a tree message type. Each one of them is converted into a struct. Okay, each one of them is converted into a struct. So now we come to the actual. Oops. The actual server itself. So this is the server. This is the interface. So when we write our server, we need to implement this service, this server. This server has one method. Okay. So which is this method is the same as what we have written here. So that's the method, right? So it takes. So okay. So it takes one parameter. Okay. So the function call takes one parameter, and this is the stream. You use this to return the result. Okay, so this is the server. This is the client. So if the client wants to connect, wants to make a call, we will have to do this. So we'll see how we use these two things. Okay, so there's a very quick overview of how we of what is generated. Okay, so what we're going to do now is that we're going to write the server. So our first part is we will write the server. Okay, we'll do the server. So to do the server, we'll just go server, go. Okay. So we will have to import a few files. And then we'll say, so in Go, like Java and C, you got func name like that. Okay, so it doesn't take argv or argc, just like that. Okay, so you can if you want to log some, if you want to import some packages, like you can say log like this, and then you can say log printf. Okay, by the way, you know, this is sort of C-like, so you can have printf and say, right, you say hello world, like that. And to run this guy, you just go run server. Okay, so that's how you run it. Okay, so for us, the first thing we are going to do is this: we will create an instance of the gRPC server. Okay, right. So we'll create an instance of gRPC server. So to do that, right, we will need the Google. We will need the gRPC package. Okay, so you import that package, and what we'll now do is this: we will now create the server using the gRPC package. The server equals to gRPC new server. So like this. Okay, so we can print it out. So the really nasty thing about Go is that if you haven't done it, if you haven't used Go, you notice that when you run, okay, sorry. Let me make a package first. Okay, so when you run, that's what the package does. You will complain that, you know, you'll complain that, oh, you didn't use this, so you give an error. Okay. So by the way, there's an error here. Okay. Right. So you'll complain that, you know, so you actually need to go like this to stop it complaining. Okay. So I'm just going to display out what is S. So let's. Okay. So that's what is displayed. So the server is this guy. Okay. So we create a gRPC server. Okay. Let me see if any questions. I'm moving too fast. Okay, so if I'm moving too fast, you know, let me know. Okay. So the next thing we need to do is this. We will create a board game service. Okay. So to create a board game service, right, we need to implement the board game service server. So we need to implement this interface. So this is an interface. Okay. So the way this interface, so we need to implement this interface. So the way you implement the interface is like this. Okay. You create a type. Let's call this board game server. So like this. Okay, so this is just a struct, like a struct, like a class or object, right? So what we need to do is this. We will need to implement this service like this. You say func, okay, and then you do a receiver as bgg server, okay, and then you put this thing like that. So basically what you're saying is this, right? This function belongs to this struct by having this part here. So this is called, this thing here, this is called a receiver. So inside the function, so let's say if my struct has got a field, let's call this name. Like that, right? Okay. Then to access that field, I can just go as name. So because S is this type, S is this one, so I can just say s.name to access this guy inside this function. Okay. So this is how you implement an interface in Go. Okay, so I need to import this package in. So this is my package, right? BGG is my package. I need to import the package in. So the way to import a package in is here. So do like this. Okay, so you can do like this. Okay, so I will write an alias to this. It does in Java there's no equivalent, so I can do an alias. So instead of typing out messages as the namespace for the message, I can just go. I can give a name. I can give an alias for this, a shorthand for this. So I will call this BGG, right? So BGG represents this package. So all these things, right? Find board game by name request. All this is part of this package. So all you need to do is like this. Okay. So this is the request, and then this is the string. Okay. So let me just put this in a new line. Okay. Okay. So basically, I'm just saying this thing can be found in this package, and this class can be found in this package. Okay. So we can return new because I'm returning some error, right? So I'll just return new for the time being. Okay, let me remove this card. Okay, understand so far? So any questions? Okay, so the code will be available in the repository. The code will be available here. Okay, it's up here. So that's the GitHub repository here. Okay. So we'll create this service. So the way you create this service is like this. So now we have implemented this, right? So we create a service like this. We go, let's call it BGG serve. Okay. So we'll go BGG server like that. Okay. So that's how you create a service, the board game server. Okay. So once you have done that, we will now register, okay, the BGG server as a gRPC service. Okay, and the way you do that is also part of the package, part of the generated package. So here, register. So you call this one, you pass in the gRPC server and your service. So like this. Okay. BGG register board game server. We pass in the gRPC service and the BGG server. Okay. So if you notice that the BGG server, okay, so the BGG server like that. Okay, I think it needs a address, so I'll just okay. So once you have done that, we can now. So now we've got the server. We need to now open a port. Open a port for the service. So the default port, right, for gRPC is 50051. That's the default port. Okay. So the way you open the port is like this. We use the Golang net library to do that. Okay, so let me put a log file here. Log, okay, printf, right? Opening port 50051. Okay, so you go like this. The connection. So the connection net dot listen. So the connection is TCP type, and we're going to open it on all our available all our available LAN port. If you got a multi-home machine, for example, you open it on all the connections, and then you say 50051. Okay? So it's not good to hard code stuff like this. You know, you can pass in through parameters. Since it's a demo, I will just hard code everything. Okay. So the net listen, right, is part of the standard Golang package. It returns two things: the listener and the error. Okay, you need to check the error. So instead of checking the error, I've written a simple simple package, simple file here to check the error. So you pass in the error, If there is error, you just log the error and you stop execution. So I'll call check error, okay? So I'll call check error and I'll pass in the error. So if there is any error, you'll stop and you just die, okay? So if there is no error, what we'll do now is this. We'll now start the board game service. So the way you start a board game service is like this. You go S is this server, okay? Serve. You pass in the listener, this connection, this port 80, right? So this one, the serve returns an error object. So you need to check it again. So like that. Okay. So that's roughly our server. So a lot of talking, but you know the code is actually very short. Create a server, create a board game service. So this is our service. Register our service with the server. Open a connection, open a port. The default port is 5051. Start the service. So let's run this guy and see what happens. So the way to run is to go run. Okay, then you have to give the two files. And then you go server. Okay, so you only do this once, and if everything's okay, you've got the server running. Okay, so what I'm going to do is this. I will write a make file so that you can run the service without having to remember what to type. Okay, so I'll call this run server, and then let me clear the screen, and then we'll go run, and the list of the files. So general practice is to go server src equals group. List the files here. Okay, right. So basically, you type make run server, you'll just run these files, right? So let's try that again. And what I'm going to do is I'm going to remove all the print line statement so that it's actually easier to see. So I'm going to remove this guy. Okay. So let's try running this again. So we go make run server. So now the server is running. Okay. Any questions so far? Any questions so far? Okay. So if you don't have questions, so what we're going to do is this, right? We are going to just print a few things out first before we actually implement the access to the database. Okay. So let's assume that somebody has made a call to this guy, right? And I am now going to pull out my data. So what are the data I'm going to pull out? I'm going to pull out. So from the request, I'm going to get the query, the limit, and the offset. Okay, so this is how you do it. Okay, so if you recall, right? If you recall the query, you go request, get query. Okay, so how do you know this? From the request, here, you've got all these methods, right? So this is my request, right? So this thing is my request, right? So I can go get query, get limit, get request. Okay, so the methods. So this is what I mean. So notice, this is the structure. This is the struct, right? This is the struct. Okay, find board game request, right? And notice these functions, in front of this function has got what is called a receiver, right? These are called receivers, right? These are called receivers. So basically it means is that the structure will have a method called get query. So this is my structure, right? This is request, right? So request dot get query because we define this function to be a receiver for this method. So that's how you implement an interface in Golang. Okay, so I can go like this and then go limit. Okay, and then I can also go get offset. Okay, so let's just print out these few values. Okay, let's print these few values. I will say this find bot game, and then we can say query equals to string, right? If you're familiar with Python, this is like your F string like that. Okay, so this one says there's going to be a string here. Then I will say limit. There's going to be a digit here, and then offset. There's also going to be a digit here. Okay, so now you provide the three things: query, limit, offset. Okay, so we will make an invocation just to see that these things are printed out, right? So if you recall, if you go back to my slides here, okay, we need a client to call, right? We need a client to call. Okay, so currently we do not have the client. So what we'll do is this: we will enable reflection. We'll use a tool in gRPC called reflection, and then so once we enable reflection, we'll use one of the tools called Evans, right? Evans, to access our server and examine our server. Okay, so the way you do that is like this. So it's very simple to enable. So you just go reflection, okay? And after you have created your gRPC server, let me put a message here. So what we'll do is that we will enable reflection, okay? And then we'll just say reflection, okay? Register. We pass in our server. Okay. Oops, what happened? Okay. Okay, enable reflection. So this one, in the future, if you really want to, you may not want to enable reflection, because when you enable reflection, anybody with a reflection tool like Evans can introspect your service and find out what it can and cannot do. Okay, you may not want to enable reflection all the time, so you want to have an option to enable or disable reflection. Okay, so now we will start running. We'll run that again. So we'll enable reflection. So now we'll see how what we can do with it. So we can go Evans, okay, which is the tool, which is this thing, and then you can say REPL. Okay, run the read evaluate print line option. Okay, and then you say and introspect the server using reflection. If you don't say anything, the default port will be 50051. So now you go like this. It's now connected to that. So you now notice that it actually knows our service. So we can say show. We can also show packages. What are the packages? So that's our package. This is the reflection package. You can ignore that. Okay. So now you can say show service. What are the services? So that's the service that I defined, the board game service. It's got one function, find board games by name. It's got one parameter, and it's got one response type. Okay, so you can go service. You can specify the service. You're going to one service. Okay, you can now go describe to us how the request looks like. So these are all done by reflection. So that's why reflection can be very dangerous. Okay, reflection can be very dangerous. So you may want to disable it, right? We can look at that, and then we can go describe the board game. That's our board game. So we can now invoke. We can now go RPC. What are the RPC? Show RPC. What are RPC available? Right. So now we can call our function. So our function is find board game by name. So the query. So remember, we need to fill up these three things, right? So when we make a call, we need to fill up these three things, right? So the query, the limit, and offset. Okay. So the query can be, let's say, Catan. I'm looking for a Catan board game. The limit, let's say I want return 20 results, and the offset 0. Okay, so now you notice that we have made the call over to here. I'm not returning any result, that's why we don't see anything. Okay, so we can try again. We can call Carcassonne. Okay, so if you don't say limit how many, and you hit enter, notice this is now 0, 0. Okay, so again, offset 0 is okay, but limit, limit you may, if the person didn't specify any limit, you may want to set a default, like maybe 10, for example, right? Okay, so that's how you use the reflection. This is for testing when you're doing development. Okay, so I just want to change a little bit. I want to say, if the limit is 0, right? I want to set the limit to maybe 10. Okay, just to set the default. Okay, so now what we're going to do is this. We're going to take this information that we have, this information, and then we are going to call our database. Okay, we're going to use this method. So we're going to pass information in here, here, and here, and then we will return the result. Okay, so rather than show you how to do the database, how to write the database, because it's not primarily about database, I've actually went ahead and implemented the database. So let me just very quickly explain to you. This is to access the MySQL code. So this is the query that we'll be executing. Okay, it's all parameterized. This is a prepared statement. So again, this thing is exactly like the query that we've shown. The result, so let me skip this one first. The result is returned using this structure. Okay, so which is exactly the same. And then to use the database, you need to create a structure called BoardGamesDB. You pass in the username and the password. This is the username and password of the database. And then you call open. So when you call open, this open, what you do is this. You open the MySQL database. If you have done gRPC or whatever, it's just looking for the driver, right? So I've loaded the driver up here. That's the MySQL driver. Okay, and you pass in something called the DSN. DSN is the connection string, the database connection string. So this is the DSN. So the DSN will take the username and the password. So notice, this is a receiver for BoardGamesDB, right? So BoardGamesDB has got username and password. So this is how you access it. You go BG, this thing here, username, password. So you create the DSN, okay? And then after that, once I've opened the database, I will assign the database to this internal structure holdings. So notice, in Go, this is like a class. Notice some names are uppercase, some names are lowercase. Okay, if your attribute, if the name of your attribute is in uppercase, it means that it is public. It can be accessible from externally. If it's lowercase, it means that it is private. It can only be accessed within the package. So this connection here, this is private. So the database that I create is private. But these two are public. Okay. And then there is a method to close it. And then what I'm going to do is this. This is the method to perform the query. So I'll come back to this in a little while. So we basically pass in the query, the limit, and the offset. Okay, I'll explain this up a little bit afterwards. So let's see how we use this guy, right? So what we will do is here, okay, we will first of all create so open a connection to the database. Okay, so the way you do that is like this. You go DB, right? So BoardGamesDB, right? So the BoardGamesDB, if you recall, right, requires two parameters. Okay, so it requires a username and a password. So you go username. The password, the username and password for my database is very simple. It's just basically fret. Again, this information should be passing through the parameter and not hard coded into your program. Okay, right? Then what I'm going to do is this. We will, after you have done this, right, we will now call open, to open a connection to the database. So open returns an error, okay? So we can say, just do a log print f, okay? Opening connection, or maybe connecting to the database. Okay, so it returns an error. So we just go check error, ed, open. Okay, again, right? All the receiver function, all these receivers, if this is lowercase, it means that it's private. If it's uppercase, it means that it's public. Okay, so open is a public method. Okay, so if there is no error, I can go defer, ed, close. So what is defer? Defer is close the database when the connection, when the program ends. So if you have done Java, right? If you do Java, this is the similar syntax. So when you open a database here, it's a db whatever, right? Okay, and then db close. Okay, so this defer is similar to this try finally block in Java. Okay. Okay, that's what we do. Okay, so we close the database when we exit the program. So now we've got the database connection, right? What do? We need to pass the database to the server. So this is what we do. We just in here, right? We say db bot game db like this. Okay. So okay. So when we create the database, just go db. You pass in the database. So we create the database. Okay. Then we, as before, so now we create the server. We pass in the open database. Okay. The other option is to create a receiver here and open the database inside your server. Okay. So like this. So let's try and run this guy and make sure that there's no error. Okay. So we've opened the data connection to the database. Right. So now all we need to do is just use the information that we have. Okay. So how do we use? So remember, we are holding an instance of the database, right? DB, right? And this is our instance. Okay. So one way you can think of this instance, right, is if you're doing Python, you have a function, right? Def. So you're writing a class, right? Okay, right? Okay, and then you have a def, right? And then some function, right? ABC, right? So self, right? For example, like this. Okay. So this thing is self in Python. Okay. So now we use this information. You say s.db. So we go s, access the db, and now we can use this function that I've written. Okay, find bot game by name, you pass in this string. So this one, what this one does is this, right? It returns a channel, an output channel. So this program, what it does is this, it creates a channel. Okay, it creates a channel, and then inside this function, it creates a channel, and then it starts a little process. Yeah, it starts a go function. This go function, it starts a separate process. So this process will run in the background, and then it will perform the query for every row, for every record. So it will perform the query. So this is my query string. Then it performs the query. Okay, so it gets the result. It checks whether there's any error or not. If there's error, this is C, the channel. We will create a result. So in here I've got a structure, which one field is called error, the other is called result. Result is whatever that you pass in, right? So if there's error, we'll fill in this guy. If there is no error, this will be nil. You pass in the result. So basically what we do here is this. Okay? We create, here when we call this function with these 3 parameters, right? It creates a channel. It then returns a channel to the caller, the person who calls it. and then it starts off this other process. So now we've got two processes. One is the caller, who's holding one end of the channel like a pipe, and then we've got this process that is running independently that's holding the other end of the pipe. Okay, so what this function will do is it will now go and perform the query. Okay, you check if there is error. If there is error, it will return the error in the channel, and then you'll close, finish, you're done. Okay, if there is no error, okay, we will do a defer on the close. Defer means when this function ends, we'll close the row. This is like, if you're doing Java, this is like result set. We close the result set, we close the channel when we are done. Okay, now we look through the records that are returned. We create one board game, we create a structured board game. We read the record from the row. So if you're familiar, again, you're familiar with Java, I'm going to use the reference to Java. So this will be your result set, right? So your result set next. Then you read the field. You check if there's error. If there's no error, if there's error, you return. If there's no error, you pass the data back, the result, and then no error. So you keep on doing this until you run out of records to read, and then you exit. When you exit, the result set will close, the channel will close. Okay, so this is an output channel. So in other words, the person who is calling this method, right, will get a channel, and in that channel, it will be receiving the query query result, and then we'll keep on reading until the channel closes. Okay, so this is what you do. Like this. So we will say, this is my channel. Find board game by name. You pass in the query, you pass in the limit, and then we pass in the offset. Okay, so this thing is this guy up here. We get back the channel. So this little thing, this little arrow here, like this is the output channel. So this channel can only read. So this is a read channel. Okay, so now you keep on looping through until the end. So the way you do is like this: you go for, right, result. Let's call this rest range C. Range over the channel and keep on reading. Okay, so the rest is this query result, which is this guy. So now we need to check if there is any error. You can say like this: if nil is not equals to rest.error. Okay, so then we need to tell our client, the person who is calling us, the error. Okay, so the way you tell is like this. So we use status and we use codes to return the result. Again, I'll let you read up on those two, right? But these are two packages you need. So we will return the result, the error like this. Go return status error F. Okay, and then you tell what is the error code. So again, the error code in here we'll call internal. There's a whole bunch of error code. So there's a whole bunch of these errors. Code, this error code. Okay, so there's a whole bunch of them like this. So the one I'm going to use is internal. Okay, so we go like this. And then we will return a string to say what is the error. Okay, so we can say this error resulted from this, and then we just want to print out the error. So I need to import FMP as well. I don't think I have FMP. Okay. Okay. Right. So it's fairly standard, the error. So if there is no error, we have the result. So now what we're going to do is this. So if there's no error, then we have this result. Okay, we have this result. So the second part here, right? So what we'll do is this. By the way, if you notice this, this result here is an interface. This is like the object type interface allows you to put any type of data here. I purposely did it was because if you take this code and you want to write your own result, right? You can just assign this. You can just assign this to this rather than sticking with one type. Okay. So this is an interface. You need to do an assert or do a cast on this interface to this type because the result, right? Because when we return the result using find by, okay, the result is a board game. So we assign it to board game, right? The result is board game, right? But this result is an interface. That means it's a general type. So we need to do the reverse. We need to get the data back, right? So the way to get the data back is like this: record. Okay, record. Then you go, you take the response, the result, and then you do this. So this is the do the assert, which we get the record. Okay, right? And then now we need to return the result. So if you remember, to return the result, we need to construct one of these guys, right? So, okay, I don't even have to count yet. So let me just do a count here. Count. Okay. So I'll create a response. Okay. Board game, find board game response. Like this. So the first thing is count. So let's go back to here. Okay. So I need a count, then I need to create the game. So count and then game. So the game is, and the game is a, so if you look at here, the game is a pointer. So you need to do like this. Okay. Right. So now you just go gID, that's the game, and we take the record. The record also has a gID. So we just do this for all of them. So name, and then ranking, and then the other one was URL. So we've constructed the response. Now all we need to do is just send the data back. Okay. So stream. So remember, sending the data back is to use this guy. Stream, send the response. So the response has to be sent as a pointer, like that. Okay. So so the rest of this stuff is just the implementation. You get the data, you pass in this one. Let me increment the count first. Okay. So we count, we check the error, we perform the query, we check the error. If there's error, we return the error. Otherwise, we cast the result or we do assert on the result to get the record. Then we construct the response, we send the data back. Okay. So let's try running this guy and see. Okay. So we got error here, 45. What does it say? What do you say? Indirect BG board game, literal BG board game. 4. Server indirect board game. Oh, okay, this is like this. Okay, so let's try running this. Why? Oh, okay. Okay, so I just make a wrong thing. I should create a pointer. Okay, so now let's try running this guy again. Okay, so let's run this guy. So we go service, board game service. So we call find board game. So we go Catan. Okay, so we want 5 results. And so now these are the results that has come back. So notice the speed. So the first one, the second, the third, the fourth. Okay, so we can call, let's call risk or pandemic. We get call pandemic, right? So limit then result. I think I spelled wrongly. Is it pandemic? Maybe I don't have it. Oh, PAN. So those are the board game for pandemic. Okay. Okay. I think I've run out of time. So what I'll do is this. Instead of doing the client, I will now do the. So I won't do the client. By the way, when I push the code, I'll write the client. The client is very easy. What I'm going to do is I'm going to do the gateway service. So currently now, right, the only way to call this server, our server, is to use Evans, or you write a Go client. Okay, you write a Go client. So what I'm going to do now is this. Instead of doing the client, which I run out of time, I will do the board game service gateway. So that's actually fairly simple. Okay, and it gives us quite a lot of flexibility. So what does the gateway do? So the gateway basically allows you creates a reverse proxy for the client to come in. So this is our service, right? So currently our service can only communicate using the gRPC protocol. Like let's say if you've got HTTP client coming in, you need to get this proto-C file to generate stubs for your client. So if you're not willing to do that, right, and you want to have HTTP interface, you can get gRPC to generate a HTTP reverse proxy for you. So the reverse proxy will take HTTP connection and convert it into gRPC and return to you the data as JSON. Okay, so we're going to use gRPC to generate this reverse proxy for us. Okay, so there are two styles of reverse proxy. The first style is, this is the gateway. The first style is the gateway runs an instance of the gRPC service, and you expose the port 8080. So the HTTP comes in through here. The gateway passes the call to here. The result comes back. So this is one way. The second way is the gateway and the gRPC service are two separate processes. The result, the HTTP request comes in. The gateway forwards the request to the gRPC service. So here they communicate as using gRPC protocol, the binary protocol. The result comes back, it goes back out here. Okay, so this is more resilient because we've got these two things separate. So we are going to implement this guy. So I've already got the service running. So this service here is running. So all I need to do is just generate this guy. Okay, so we need to make some modification to proto-C, and then we will write a small program, a simple program to get this gateway up and running. So this is the package for it. I've got the picture from here, and this is how you do the gateway. Okay, so what we're going to do is that we're now going to do the gateway. So we'll go back to this file, right? Profile, right? And we'll import in Google/API/annotation. So like this. Okay. So then what we need to do is this. So this is so for every method that expose as HTTP, we need to say how we want to expose it. Okay. So the way you do that is like this. Inside the body here, right? So let me just put it up here, right? So inside the body here, this body here, you go option, okay? And then you say google.api.http equals to this. And then now you say what method you want. You can go post, you can go. So this is a search, just do a get. And then you need to specify the endpoint. Okay, what's the URL, the endpoint? So maybe I'll say API v1 search. Okay, so the really cool thing about this is that if you do this, right? So remember, to invoke this method, you need these parameters, right? All these parameters will automatically become query string. So all you do is specify a query string. That's one way, right? So to call this, right, all you do is just this API v1 search, like query Katan, like that. That's one way. Okay. Another way to do it is, if you want the query to be part of a URL, you can do like this. So this little bracket here is special. It says that this thing should be mapped to this. Okay. Then the gRPC gateway will know what to do. So for our case, what we're going to do is that we're going to use this more generic method. Okay, like that. So you can say query Katan, and then you can say limit equals to 10, offset equals to 5. Or you can leave it and then they'll just do the default. Okay, so this is what we're going to do. So this is the modification we need to make. Import in the package, and then add this little bit here. Add this little bit here. Okay, the documentation is here. You can read the document. You can do a lot more. So this is one. Then we need to go and change the make file for generation. Okay, so we need to go like this. We need to go I. Okay, we need to go this thing. Go path. Go path is part of the Go. Let me exit this guy. Okay, so Go path. Set go grep go. Okay, so when you do go, you need to set 3 parameters, 3 environment: go bin, go path, and go root. Go path is where your projects are. Okay, so that's where go path is. So go path, you need to know the name of the, again, everything is written here inside the example. Okay, so let me just do this. So SPC github.com, and then you say gRPC ecosystem, gRPC gateway, third party, and then Google APIs. Okay, like this. So tell it where to search for the additional files that we need. And then we also need to tell it to generate, besides generating the gRPC, we also need to tell it to generate the gateway. So it will be gRPC, the option is gRPC gateway out, okay, log to standard error equals to true. And you just do like this. So that's the modification we need to make. So now we can generate again. Okay, so now it's generated. So let's go and look at the file. So as before, we will still have this standard file. The other thing that it has is this new file that's generated, the GW. This is the gateway file. Okay. So the gateway file, the only thing that we need to worry about is this 2 method. So the first method takes an instance of the board game server. So this one is this style. The second one, line 79, this one takes an endpoint, is this one. So it forwards a request over to here, the result comes back. So this is the one that we are going to use. Okay, so we will write a proxy connection. Okay, so let me just go this first. So package, you put it in the main package. Okay, then we'll import. Okay, okay, so we will go like this. So we'll go like this. Gateway ecosystem runtime. Okay, so we'll go func. So like that. So the first thing we'll have to do is this. We will have to create what is called a server mux. Okay, a multiplexer essentially. So we need to create this guy because this is just a multiplexer. The request comes in, it takes the request, hand it off to this guy. Okay, so to create a mux, go like this, mux. Okay, sorry, not gateway, not gateway. So this is the runtime. So we go runtime, new serve mux. I think that's what it's called. Okay, so let me just do a print line of this guy first. Make sure I get it. So we can go log, okay, print f. Okay. I just want to print out just to make sure that I'm not getting any error. Okay, so let me run this guy. So the way to run it is you go run proxy. Okay, so that's correct. So we create the mux, we create a multiplexer. Okay, so the second thing we need to do is this: we will create options for connecting to the proxy, to the service. So, okay, we'll set options for this guy. Okay, so the options will be this. Okay, so we create options, OPTS. So we create an array of options. It takes an array. So gRPC val option. Okay. So this is how you initialize. So this one says that it's an array of gRPC option, and this is how you initialize it. So what I want is this. So I want to create an option to connect with using insecure, that means non-SSL connection. Okay. Then the third thing is to register the proxy with the service. Proxy, okay. Register the proxy. So this guy. So basically this guy. Then we call this guy. Okay. So this guy is inside the directory before. Let me just do this first. Okay. So it's inside here. So what we do is like this. GW. Okay. So we need something called a context. So this is context is basically the way how Golang passes data, control information like timeout, cancel, whatever between processes. Okay. Again, I'll just use CTX like this. Okay. So what I'll do is this. I'll say CTX background. Okay. So the second thing I need is a mux. I've already got the mux up here. Okay. Then I need the endpoint string. So the endpoint string will be localhost 50051. Right? So I'm running locally and the connection is 5051. So this, in other words, this guy is running localhost 50051. Okay, and then finally the options. Okay. So this function returns an error. So I'll just go check error. Like that. Okay. So what I'll do is this. I'll put this line up here, and then I'll say registering the proxy. Registering the proxy. Okay. So once I've registered a proxy, now I will open up the port to allow connection in. Okay. So open the 8080 port to allow HTTP traffic. Okay. So for that, I will use the Golang's HTTP package. Okay. So this is what you do. Go HTTP, right? Listen and serve. Okay, so we are going to listen again on port 8080, and then we pass in our marks. So I will say here, let's put a little message here. It says, okay, opening HTTP connection on port 8080. Okay, so this one returns an error. Again, we'll just do a check error here. Okay, so that's a few lines. You can do a lot more with the proxy, but I'll just leave it like that. Okay, so let's run this guy. So let me do a makefile for you to run this guy. Okay, so this is run proxy, and then I will have the, sorry, not proxy, gateway, which is also proxy, gateway source. So gateway source is equals to, so let's go. So I don't need this guy. So like this, okay? So let's try running this. So I will now go make run gateway. Oops, gRPC. There's an error. gRPC. Is the error? Line 20. Okay, gRPC. Okay, let's run this again. Okay, so now the connection has started. I need so much play. So I'm going to use HTTP. So if you recall, right, our API is like this. Okay, so that's our API. That's our API. So now we will go gRPC. gRPC localhost port 8080. Okay, so API v1 search query done. Okay, and you get back the result. Okay, so if you notice, that the data return is in JSON, and it's coming from the gateway. So we return a gateway. So just by using a few lines, you can practically cut and paste this, and you get your gRPC connection available as HTTP. Okay, so I don't have time to do the client, so I will stop here rather than trying to rush through and do the client. The client isn't really very difficult. What I'll do is this. After this, I'll push my source code, and then I'll write the client as well, and I'll show you how to build it. Okay, so finally, after you've done all this, right, you want to make a binary file out of it, right? So let's build a binary instead of doing run all the time, right? So you can say build all, okay, and then we will say make directory -p bin. Okay, so now to build, you go build, okay, then you go -o. What's the name of the file? So when we build a server, let's call this BGG server, and then we'll pass in our server source. Okay, same thing. You do the gateway, and then this is the gateway source. Okay, so now we can stop all this guy. Okay, and then we can go make all. So it will now build the two files. So now you can run them. You can just go, make sure you set your path to this. You can just go bin, BGG server. That will start the server. Bin, BGG gateway. Okay, so if you just run the server, then you can run your events. Okay, you can go call. Okay, risk. So those are the risk game. Okay, you can also run the gateway, and then now you can go HTTP. This is HTTP Pi, by the way. If you're using Linux, you should try this. This is really cool. Instead of using curl, I still use curl, but this one actually formats it for you. Curl doesn't format. To use curl, you have to use JQ to format. HTTP Pi actually formats it for you. So localhost, right? 8080. Okay, API v1, let's say search, right? And then you now say query, equals to another one is Twilight Imperium, Twilight ILIGHT. Okay, if you want to put a space, you must encode it. Okay, so those are the Twilight Imperium. So the %20, right? By the way, just to very quickly show you, if you want to like put in a command line, now where's the proxy? Okay, I'll do the proxy. Okay, let's say you want to put in a command line, right? To change this port number, right? Maybe you don't want 8080, right? I'll just show you very quickly. You can use the package called flag in Golang. So what you do is this. After this, I will stop. Okay, so we want our option to be like this, port, right? Maybe you can set 3000, right? But the default is maybe port 8080, right? So the way you do this is like this. So this is a number, right? So you can say port equals to flag. So you want a port, this number. So this is uint, unsigned integer. So this is the name. Sorry. This is the name. This thing is this thing here. Then you give the default. Okay, and then you give a help string, right? HTTP port. Okay. So after you've done that, you can go flag pass. Okay. If you type it incorrectly, it will automatically stop you. You give you error messages and stuff like that. So now you got this port. So this is actually a pointer. Okay. So now to use this guy, okay, you need our FMP. You cannot just do string concatenation. You need to create the connection. You need to create this guy, right? So you can go connection string. Let me just put it down here. So you can go connection string. FMP sprintf. Okay, then you can say .000 %d, right? Then you pass in the port. So remember, this is a pointer. This guy is a pointer. So you need the content. You need to do a star like this. Okay. So this one also you may want to just do this. Okay. So now we can say connection string like that. Okay. So let's build again. Okay. So let's kill this guy, and we can now go bin bgg gateway, right? You can now. So if you put error, let's say like ABC, you get. Oops. Okay, so you can see that it's got more of this, right? So you can go bin bgg proxy gateway, right? Port, let's say I want port 3000. So now it's listening to port 3000. So now we can do the same thing again here. Instead of port 80, we go 3000. Okay, right? Okay, so I will end the presentation here. Let me check in the source code first. Okay, so we do not want. Okay, we do not want. I don't want a few things, so you have to build it up yourself. What we'll do is this. What we'll do is this. I'll create a git ignore file. Oops. So we do not want everything inside the bin directory because you have to generate that. Right? Mine is running on Linux, so you shouldn't take my binary. And then under messages, we do not want the Go files. Okay. So let's go back and let's see a status. So yep. So we can stage all of them. Okay. And then we will now go git commit. Okay. So we actually have files for created. So we actually got the server. and the gateway. Okay. Okay, so I'll push the code up. Okay, I will end here. When I got time, probably you can do a poll tomorrow. I will do the client so that you can look at the client as well. Okay, so I'll end here. If you got any question, I can take some questions. Otherwise, thank you for coming. Any questions for me? I'm sorry if it's gone a little bit too fast. You know, do let me know. Okay, so I got a question here. What is the role of the server mux in the translating HTTP? So the server mux where's the gateway? Where's the proxy? Okay, the proxy here. So the server mux is basically this thing. It's a reverse proxy. Okay, so if you look at how Google's HTTP, Golang's HTTP work. So in Golang's HTTP, generally what they will do is this. Where's the go doc? Okay, go doc. Okay. So the HTTP, generally what they do is this. Think of the server mux as a server that is running. And what they will do is this, it will receive the request, hand it off. So the server mux, in this case, behaves like Nginx. If you know what Nginx, right? So it behaves like that. Understand? Okay. How is backward compatibility maintained managed in gRPC? So okay, so there are two compatibility here. The first compatibility is actually on the gRPC level. That is maintained essentially by the runtime. So that is okay. The other one that you need to maintain the backward compatibility is this guy. Never ever change this once you put it into production. Never ever change the tag once you put it into production. Just continue extending, but do not ever change this. Okay? Right? So any other question? So I do hope you get a chance to play around with gRPC. gRPC or RPC and gRPC in particular, it's not very flexible. Every time we need to introduce a new method, you need to come here, compile, go to the server, go to your server, go to this server, write all this thing, and then put it into production, right? So if you want speed, I think RPC will probably not suit you. But what RPC does is this: it guarantees compatibility, first of all, between platforms. This is what you get when you use RPC and gRPC in particular. You get from one file, you get the stub and the skeleton, and the stub and skeleton can be generated for any language. And gRPC guarantees this will communicate. So today, right, when we have multi-platform from different programming languages, we will for data communication. Essentially, we are just passing messages, right? We use JSON or XML. JSON and XML, right, is only passing data. Okay, it doesn't address things like how do you pass large payload? What happens if there's an error, etc. You need to define all that mechanism yourself. Okay, just like HTTP, right? HTTP only tells you 404 something has gone wrong, right? How you do the recovery, everything is you have to do it yourself. Whereas in gRPC, in RPC, all this is covered under one framework. Okay, so that's one. The second thing is this: you get to pass very, very precise data. So if you're working on passing data, and the data has to be really, really precise, right? Like in 32, unsigned 32, etc. Okay, This is another thing that RPC gives you that you cannot get with HTTP. HTTP essentially basically doesn't have like a data type, okay? And if you use JSON, JSON is basically based on JavaScript. There is no definition, there's no specification for floating point. Number is just a number, okay? So in gRPC, you got all these different types. I haven't even shown you repeated types. That means you can have repeated fields in here. And then you can have things like, enumerated types and stuff like that. Those are some of the more advanced usages. So while gRPC is not very flexible, it requires a lot of work, right? But once you know what are the methods you want, it can be very, very convenient because all you need to do to generate client is just this file and nothing else. Okay, and this file describes everything that you need for you to implement both either the client or the server. Okay, right. How does gRPC improve? Okay, so what I did, let me show this. Remember, we talk about insecure when we do the connection here. This thing here, you can actually do it with SSL. Okay, you can do it with SSL. How does gRPC address or improve security? The second thing it does is this: under the hood, it uses HTTP2 as a protocol, so it's faster, it's more secure, you know, in a sense. Okay. Okay. Any chance to compare gRPC with Thrift? Okay. So any chance to compare gRPC with Thrift? Thrift, as far as I know, I haven't worked with Thrift a lot, but as far as I know, Thrift is actually a message, a library to pass messages to data interoperability. In other words, you know, you can have different messages pass between different platforms, right? Windows between Linux, you know, etc. Okay, so Thrift is like JSON or XML. So the gRPC, right, is actually composed. I probably should have mentioned this on the get-go. gRPC is actually composed of two parts. The first part is this thing. This is called protobuf. So you can actually use protobuf without gRPC just for message passing. Okay, so if you go and look up article and you want to transfer messages, just messages between platforms, okay, either using HTTP or some other protocol without gRPC, okay, you can just use this. You don't have to have this. So in that sense, the protobuf is exactly like Thrift. Okay. Any other messages? Okay. Okay, so I think we will stop here. Again, please pull tomorrow. Please pull the code tomorrow. I will do the client, you know, later today, and then you can have a look at the client. Okay. I'll change the make file so that you can have a look at the make file. Okay. Right. I think that's all. Thank you very much. Unless you got more questions. Okay, don't forget our upcoming, the next one I think is done by my colleague on doing time series data on time series analysis on DataGov, right? 2 weeks from now, I think somewhere in mid-June. Okay, thanks. Bye.